everyone, my name is Frederic Fan. I'm a senior researcher at the Music Technology Group of Universitat Pompeu Fabra. In this video, I'm presenting recent research carried out around the idea of a hardware music sampler that integrates with Freesound and offers several ways of retrieving content from it. For those who don't know, Freesound is a sound sharing website where people from all over the world create and share sounds under Creative Commons licenses. Currently, it hosts more than 500,000 sounds that cover everything from sound effects and field recordings to music loops and instrument samples. Freesound was started in 2005 at the Music Technology Group. For a number of years now, I've been the main responsible for the Freesound website and related research projects at the MTG. This is in fact where the motivation for this work comes from. As a Freesound user and researcher, and also as an audio practitioner myself, I've been thinking about the idea of interfacing with Freesound through a hardware interface and see how this could be integrated in a live music making setup. The idea of interfacing with Freesound from a dedicated hardware music making device like those behind me, which typically do not have a big screen nor a keyboard or mouse support, is a challenging one, and it is indeed very related with prior work done by many researchers in the past, including also work done here at the MTG. The result of the research that I'm presenting here is a device called Source. In this video, I'm going to talk about Source, closely following the contents of the paper, but I'm not going to do any demonstration. To hear Source in action, you can watch the demo videos linked in the description. Source is open source, and the code, including builds, can be accessed at the URL also linked in the description below. Source draws inspiration from traditional music samplers and implements many sample-playing features commonly found in those devices. Music samplers are well-established hardware devices commonly used by audio practitioners. However, the ways in which commercially available hardware music samplers interact with audio collections are rather limited and have remained mostly the same since the early mass-produced digital samplers. Typically, the process of loading samples is a manual and time-consuming one, involving an SD card onto which samples can be loaded using a computer and then the card plugged into the device. There are some computer-based tools that can facilitate this process, and to mention an example of these tools very related to Source, it is worth pointing out the Volca Freesound, which can transfer Freesound sounds to the Volca sampler directly from the web browser. Nevertheless, I believe that music samplers could boost their creative potential by providing innovative ways of interacting with large audio collections and in particular with online sound collections which can be regularly updated, such as Freesound. In the context of desktop computers, however, there has been many research efforts exploring novel ways of interacting with large audio collection. I'll mention some of them, with a special emphasis to those related with Freesound, as those are also especially relevant for Source. To start, the Freesound website itself incorporates a similarity search feature that allows users to retrieve sounds which are acoustically similar to a given example. This provides an alternative to text-based queries. A similar notion of acoustic similarity has been used in Freesound Explorer, a sound exploration and music-making tool that projects the results of a Freesound textual query into a two-dimensional map where close sounds are more acoustically similar than distant ones. It is also worth mentioning the case of the Freesound loop generator, which features a step sequencer in which short sounds from Freesound are automatically loaded after the user introduces a textual query. In this case, the interesting idea is that users don't choose exactly what sounds are loaded in the sampler. There also exist commercially available software tools that include advanced ways of navigating audio collections and loading sounds into a sampler. For instance, XO is an audio plugin by Excellent Audio which analyzes users' local audio collections and generates a 2D map for navigating them. As another example, LoopCloud by Loopmasters also analyzes users' local audio collection to extract semantic descriptions that can be used to navigate such collections beyond the classical hierarchical folder structure. Finally, there also exist commercial samplers integrated with online sound collections such as Audio Texture by LeSound, which is in fact integrated with Freesound, and Arcade by Output, which is connected to a big proprietary collection of sounds and loops. Source extends the classic idea of the hardware sampler by being able to search and download sounds from Freesound. Furthermore, Source incorporates some innovative ways to retrieve content from Freesound inspired by the previously mentioned works, and it can be extended to carry out further research in such directions. I believe the ideas behind Source are well aligned with the emergence of the Internet of Musical and Audio Things paradigms and the concept of smart musical instruments. Source is composed of a number of software processes that run on a hardware solution based on a Raspberry Pi 4, the Elk Pi Hat for the Raspberry Pi, which provides low latency multi-channel audio input-output, and the Elk Blackboard controller board, which provides the user interface elements, including buttons, faders, a display, and the audio input-output connectors. Here is the block diagram of Source. All software processes run under the Elk Audio OS, an open-source operating system optimized for low latency and real-time audio systems. The core of Source is the sampler engine, which is implemented as a BST plugin and is run by a plugin host bundled with Elk Audio OS. The communication with the sensors of the controller board is also carried out by the OS. Finally, a glue app is responsible for connecting all the subsystems together, handling the user interface and communicating with Freesound to search and download sounds. Even though all of the features implemented in Source can be controlled using the user interface elements in the controller board, Source also offers a complementary user interface that can be loaded in a web browser and facilitates things like introducing query terms. The complementary interface can also be used as an alternative way to control Source when the Elk board is not available, which effectively allows Source to be run without the Elk hardware stack. In fact, together with the Elk builds, plugin builds are also provided that can run on desktop computers and use that complementary interface. As a summary of the sampler engine features, Source implements start-end and loop start-end positions, a classic ADSR amplitude envelope, a resonant low-pass filter with its envelope, pitch modifiers, and a number of assignable modulation options that support note velocity and aftertouch, including also polyphonic aftertouch. The most interesting bit about Source, however, is the way it interacts with Freesound. Essentially, Source provides methods to generate new sampler presets by searching and loading sounds from Freesound. In summary, these methods include loading new sounds after a user text query, replacing existing sounds using the Freesound similarity feature, and loading or replacing new sounds, randomly selecting sounds from the pool of 500,000 sounds from Freesound. In all cases, a number of filters can be applied, including sound duration, license, and even a filter for high-level perceptual qualities, including things like brightness, hardness, or depth. Please see the demonstration video linked below for more information about that. Playing with the methods above and the filters, Source can be configured to generate new presets which can be useful to make percussive instruments, instruments to be played chromatically, or even sets of music loops, for example. To finish this presentation, I'd like to say that rather than as a finished device, I see Source as a proof of concept of a system that can be further extended to carry out research about the interaction with large audio collections beyond the computer, keyboard, and pointing devices interaction paradigm. Because of its open source nature, modifications can be introduced that meet the specific needs of researchers and audio practitioners. I expect to continue developing Source in the future and make it evolve into new directions. I'm also open to external contributions and would like to see Source evolving into a community project. Thanks for watching this presentation, and I hope you enjoy Source.